In this video, I want to define a logarithm and show how to evaluate particular logarithms. Let's suppose we have some exponential, a to the x equal to y. As an example, 3 to the 4th is equal to 81. A logarithm is very much related to an exponential. The base of an exponent is the same as the base of a log base a. Once we have the base, we move to the other side of the equation, y, so it's log base a of y, is equal to the exponent, x. To go the other way, the base of the exponent is the same. Raised to the x power is equal to y. As an example down here, this is the same as log base 3 of 81 is equal to 4. So what is the logarithm? Why do we do this? Why do we have this function? Well, the idea is it tells me what power I need to raise 3 to get 81. So this is what log base 3 of 81 means. What power of 3 is equal to 81? So let's look at some examples of evaluating these. Let's start with log base 5 of 1. So what I want to know, 5 to what power is 1? That's what the logarithm is saying. What we do is we set it equal to x, and then we convert to exponential. 5 to the x power is equal to 1. Well, from here we can figure out that x must be equal to 0 since anything to the 0 power is equal to 1. So log base 5 of 1 is equal to 0. So this is what the logarithm is wanting to know. Here's the base of the exponent. Here's what it's equal to. So what is the actual exponent? In general, log of any base whatsoever of 1 is always going to be equal to 0 since 0 to any power is equal to 1. Next, log base 7 of 7. So 7 to what power is 7? We set this equal to x. Here's the base, our exponent, and this is equal to 7. And we can look at this and see that x should be equal to 1 since 7 to the first power is equal to 1. So log base 7 of 7 is equal to 1. And in general, log base b of b is going to be equal to 1 since a number to the first power is equal to itself. What about log base 4 of 64? Well, our base is 4. The exponent is x. And this should be equal to 64. 4 to what power is equal to 64? Well, 4 squared is 16, and 4 cubed is 64. So x must be equal to 3. Log base 4 of 64 is equal to 3. What about log base 8 of 2? Well, here's my base. I'm raising it to the x power is equal to 2. So what is x? Well, one thing we might recall is that the cube root of 8 is equal to 2. So that would mean x is 1/3. 8 to the 1/3 power is equal to 2. What about log base 5 of 7? In this case, I have 5 to the x power is equal to 7. So 5 to what power is equal to 7? Well, this is a hard question. 5 to the first power is equal to 5, and 5 squared is equal to 25. So really all we can say is that it's somewhere between 1 and 2, and probably closer to 1 since 7 is closer to 5 than 25. So a lot of times we cannot calculate these directly, and we need to use computers and calculators to do it for us to get a more exact answer. Next, I want to look at two special types of logarithms. First is the common logarithm, and this is log base 10 of x. So base 10 is known as the common log, and we usually just write this as log of x. So if you do not see a base on the logarithm, that just means it's going to be base 10. The other important one is the natural log. This is base e. So this is log base e, and is typically written as ln of x. So let's consider the log of 1000. I don't see a base on this logarithm, which tells me that my base is 10. My exponent is x, and this should be equal to 1000. 10 squared is 100, and 10 cubed is 1000, so x is equal to 3. What about ln of e to the 5th? Well, ln is how we denote the natural logarithm, the base e, raised to the x power, is equal to e to the 5th. And here it's pretty easy to see that x has to be equal to 5.